I'm joined by a distinguished panel of experts. We have Roz, who's a senior consultant in our UK team, and Ted and Dave from our US office in Chicago, who are directors of data science and consulting services respectively. Between us, we have well over half a century of MMM experience, so it should be an interesting conversation today. In terms of the agenda, we'll start off with why you need response curves and why just relying on average ROI figures from an MMM just isn't enough. Then we'll get into some maths. So what are the different types of response curves and some of the considerations when you're estimating these kind of curves. Next, we'll cover how to actually apply response curves to support decision making in planning and why that involves some nuance and can cause some complications. Then we'll discuss some war stories from the real world and some of the things that can go wrong and certain things to avoid. And finally, we'll round off the session with a Q&A. So if you do have any questions as we go through the webinar, please use the Q&A feature and we'll try to cover as many of those questions as we can. But before we dive in, what do we actually mean by a response curve? So put simply, it's a mathematical equation that defines the relationship between some input factor on the x-axis, which in our MMM use case is usually media investment or units like impressions or GRPs, and then the impact or effect that that will have on some outcome. Again, often that's sales in a marketing mix model, but it could be something else. Now, what's useful about curves is that they summarize in one single view what could be expected to happen in lots of different scenarios with different levels of investment. So this all seems simple enough, but some of the complexity with response curves comes from the fact that, firstly, there are many different types of equations that will have different types of curves with different properties. Another complexity is how to go about estimating them, and there can be challenges there. And finally, that what you show specifically on the axes, both on the x-axis and the y-axis, can make a significant difference to how the curves should be interpreted. So some care is required when actually using these things in practice. So with that, I'll hand over to Dave, who will take us through in a bit more detail why we need curves.
Thank you, Phil. Okay, so let's just start out with a kind of a common response curve, the C-shaped curve. It's called the C-shaped, so it looks at the top of the C, and incorporates diminishing returns. So it's fairly intuitive, and why do we use this? Well, we use it because we think it's how the world works. So you think of a media tactic. On the x-axis, basically at low levels of spend, there's a high impact initially because the media spend is primarily impacting reach, meaning we're hitting more and more people. As we move along the curve, it tends to exhibit diminishing returns because as you get to higher levels, you've hit everyone in your target audience and now you're primarily impacting frequency. So it's a fairly intuitive, this is intuitive to most people. When I show it to them, because diminishing returns exists for a wide variety of situations. Let's take a deeper dive into the curve itself, because there's two key items coming from the curve. So the first, let me talk about the average ROI. So the average ROI is really simple. It's represented by the slope of the line from the origin to the orange circle. And it's basically just the incremental sales, which you get on the curve, divided by the total spend. However, that's only one point. A more important point, I think, on the curve is the marginal ROI. So the marginal ROI is in orange. That's the orange arrow. That's the slope of the response curve. It's basically, what's the impact if I increase my sales $1 starting from the initial spend? And so for a curve like this with diminishing returns, the marginal ROI is always less than the average ROI at every point. Okay, and then in addition, you can have more complicated response curves. So the S-shaped curve is more complicated and more difficult to estimate, but it incorporates increasing returns at low levels of spend and diminishing returns at high levels. And so, why would this occur? Well, sometimes at a low level of spend, it has a wear-in effect, meaning that people need to see the ad more than once for an impact. So either they're distracted and only get part of the message, or the product itself is complicated and they need more ads for it to sink in. But after it passes the threshold, when it gets to the middle of spend, then it behaves like a C curve. You get the rapid increase in the middle, and then it declines, at higher levels of spend when we hit that, when we're impacting primarily frequency, and we're hitting that diminishing returns point. Okay, but let's talk about, why we're using curves at all. And I think the best example is when you have a couple different media channels and you're allocating dollars between them. So in this example, I have TV and radio. Radio's in orange and TV's in blue. And so I circled the average ROI. So the average R, in this case, at the $5,000 initial spend, radio has a higher average ROI. So you might think TV's better. However, average ROI is only part of the picture. It doesn't really give you a good indication what happens when you allocate dollars. The better item to use is the marginal ROI. So the marginal ROI is basically, again, the slope of the response curve. So if you look at the orange arrow compared to the blue arrow, what you can see is TV has the higher marginal ROI versus radio, meaning that if I had an extra dollar to spend, I would put it into TV instead of radio and get a higher impact. And in addition, we use this for optimization because you could, if we started with both TV and radio at $5,000, you would basically, you could take dollars away from radio, put it into TV, and so you would move along the curves. Basically you would move to the point where the marginal ROIs were equal, or the slopes were equal, and that would be the point of optimization. And so that's one really key important point with the curves. Average ROI is difficult to use for optimization. Really using the curves and the marginal is the best way to go. And with that, I think I will turn it over to Ted to talk about some of the math behind this.
Thanks, Dave. So I'm going to start with some algebra, and that might take you back to high school, or if you were ahead of the curve, maybe middle school. I don't know. But regardless, we're going to start as simple as we can, which is with a linear response. I think the first thing to call out is Dave just gave us a lot of reasons why we shouldn't use a linear response, right? Effectively, with a linear response, we're saying the marginal ROI is always equal to the average ROI, and each increment of effort will return the same. So right on the face of it, you might not like this curve, but let's talk about the function form a little bit, and then a few more comments. So in this curve shape, alpha is going to be the base level response, the intercept, if you will, when our effort is 0, if that 0 is possible. And beta is going to be that amount of return on each increment of response, the slope. One use case for this curve that I just want to call out is if we're going to stay very close to a constant level in our history, and we don't have a lot of information about how our system responds to changing levels, then we might like a linear response because it's simple and we don't really have information to inform our curvature amount. But typically, you're not going to do this for marketing mix. You're going to want a curve. That's why we call them response curves and not response lines, right? Maybe the simplest curve that we're most familiar with is a natural log. So that's this formula here. Again, our alpha is our intercept. Trickier here in that if you want your response curve to go through 0, where you can't take the log of 0, there's some tricks we use, which we can discuss if anyone's interested. They're not really amazing. But the main point is you do get diminishing returns, and you might choose to use the log if you think that for each constant multiple or constant percent increase in your effort, you should see a constant return, right? So, we typically use this for negative response curves on price, for example. One reason most of us don't love these for marketing is not just the issue with the 0 point, but also that you can see it saturates very quickly, right? The log compresses all the change in slope, it feels like, to the very bottom of the x-axis, and we don't necessarily love that. So if that's you, you also don't love that, you might try a more complicated function. An example is addbudge. Addbudge is fun because it's been used since the late 60s. John Little introduced the name, which I think is some shortened form of advertising budget. He has some nice comments in the paper that's a link to in that title. I really recommend you read. He justifies this shape a bit. He has some fun stories about talking to marketing managers about it. It's interesting to see how little marketing advice from econometricians has changed since the 60s, right? We think this is modern, but actually he was doing it back in the 60s. All right, so let's talk about the functional form. Again, we have an alpha, it's an intercept. Again, if we believe there should be zero response when there's zero effort, you're probably going to set that to 0. That's how these shapes are drawn. We have beta, which is again serving as our sort of key coefficient. That's the amount of return per adjusted unit. Then we have some more parameters here. We have a rho in the denominator and a gamma all over the place. What's really fun about addbudge is, Dave showed us a C curve and an S curve, and you can move between the two with the addbudge function. As gamma goes from 1, you have a C shape, to increasingly large startup effects as gamma goes above 1. So I've drawn a gamma equals 1 and a gamma equals 2 curve. And there's some language here about sort of an intuitive understanding of the shape is that as you increase gamma, the slope of the middle bit tilts around a point that's defined by rho and alpha and beta. All right, so just a few more comments on this. If gamma is 1, this is the Nicholas-Menten function. Some marketing mix providers push that. It's the same function. If gamma is free, like in our varying case here, this is a Hill function. Facebook's Robin, the MMM open source package, uses the Hill function. They are all the same functional form. They are sourced through different historical contexts. But just a heads up, it's really all the same stuff. So that's a bunch of options, and just some advice on how to pick. The first thought is that, as always, when we have the option of more parameters, our model fit is always going to not get worse if we add those parameters, right? But the more complex curve shapes do require estimating more parameters. And that's why I think anyone who's been through a regression modeling course, either in school or afterwards, has been told that models should be as parsimonious as possible, right? That's a counterbalancing principle so that we don't just stuff a bunch of parameters in our model, which leads to its own set of problems. Where we don't want to be too parsimonious, though, right, is when we know we have diminishing returns and we do have historical varying effort levels, so that we can detect that curvature. Because from our understanding of how marketing works, we know there should be diminishing returns, right? Just like Dave told us, when we first start spending, we're probably going to grow reach without too much duplication. And then as we start to spend more and more and more, and we saturate that outreach tactic, we're going to have people seeing the same ad copies over and over and over again. And that at some point can't be as effective as the first response. So personally, I would say that's enough. You just need the marginal returns to diminish. Many people do feel that an S-shaped curve is better, and that they have seen or feel like they have seen startup effects at low levels of spend where there's a breakthrough inflection point and then return really takes off. And so if that's your theory of how marketing works, you are going to opt for an S-shaped curve. And then, as I mentioned about why we have parsimony, it's important to know that just because the fit is better, that may not mean you need that more complicated curve. And for me, that means I don't use S-shaped curves at all. but for you, it might mean you truly believe in them, and I'm going to not necessarily rely on fit alone to determine how many parameters I use. That was a lot of hand waving, and perhaps the algebra felt a little complicated. Roz, though, is going to take us into some maybe more complicated complications, but certainly more conceptual ones.
Cool, thanks, Ted. Yeah, so I was going to talk through again. We're using this word complicated a lot, but talking through more about how we now apply curves and use them to make kind of forward planning decisions, rather than when we're looking at modelling, trying to choose curves, design curves, what we need to estimate them. And so the complications that we're thinking about here is bridging the gap between modelling and then planning and applying the curves to forward-facing decisions. So one of the mismatches between modelling and planning, well, there are two buckets these fall into. There's the time dimension for the payback of advertising, and then there's also the way we use curves in unison to aggregate them together to make decisions. So let's delve into the time dimension first and have a look at some response curves and where time actually goes and how we incorporate time. So the reason it can be a challenge to incorporate time into a curve is because of the common use of ad stocks in a model. So what are ad stocks? Ad stocks, sometimes called carryover rates, they exemplify the theory that media impact will not only be felt in the weeks that media has been seen by an audience, but also in the following weeks at a varying degree of decay. So an ad stock function will therefore force the media investment to kind of get stretched across time, measured in the model across those times, and it creates this kind of orange section that we're seeing drawn here. This orange section can then be helpful to actually incorporate time into a response curve. And we can see here how the orange section's been moved across to the x-axis of our response curves as the ad stocked media impact. So here what we're plotting on the x-axis is that every week's effective ad stocked media level, and on the y-axis, as quantified by the model, the contribution that media, ad stocked media, is actually having in that week. So time to put your thinking caps on. We've drawn a curve here that has the ad stocked media impact in week on the bottom and the model contribution on the left-hand side. So I've plotted a curve that looks like that, and I've plotted the fellow decomposition chart. So just to explain, the decomposition chart's showing from a model the incremental model contribution that we've measured through time. So the question I'm posing is, considering this form of response curve, would you expect that the sum of the contributions plotted on all 22 points of the curve would equal that of the sum of the 22 weeks of contribution we see in this decomposition chart on the right? So to add some colour just to help us figure this out, yeah, we can see here that on this type of curve with ad stocked media along the bottom and model contribution up the side, we see that all of the dots on the response curve do indeed add up to the model contribution at that given time period, which is nice and simple. But that's the start of a bit of a dilemma. And the issue is that often when we talk about planning, we want to ask the question, if I spend a certain amount in week, what do I get back? But we can't quite read that off this curve because this curve has got ad stock built into our media planning. So we have to plot a different type of curve to answer that question of what if I spend a certain amount in week. So the predicament here is that there are two ways you can actually calculate this contribution. You can calculate the immediate contribution that you see of any media in a week, or you can calculate the longer term tail of that impact going through time. So here I've illustrated what these two options effectively mean. In the top charts, I illustrate the immediate contribution from media being what you see in the week. And on the bottom two charts, I've illustrated the immediate plus the tail of the ad stock in the subsequent weeks. Conceptually, the bottom chart gives us a more accurate illustration of the impact that media has, but this adds some complexity. Think about it. If we have a media channel with an ad stock in place, and we want to measure the uplift of a given week, we would need to consider what's happened before. Because if activity is run in previous weeks, the starting point of the ad stock is not zero, so the model contribution will not be as high because the diminishing returns are harsher. So we'll always need to consider what happens before if there's an ad stock on a channel, and therefore we need to be careful with how we use our curves. So moving on to another complexity that comes from planning with curves is how we aggregate curves together, more appropriate for planning. Many clients, for instance, want to do scenario planning on a monthly or quarterly or annual basis, but typically an MMM model will produce a curve on a weekly performance. As I've touched upon, the build-up of media can have a really powerful impact on the final contribution measured. So we need to make some assumptions about the flighting of that media, and that becomes very important to then how we plot our curves out. Thinking caps on again. Here we have three laydowns for £1 million worth of media spend. We have plot A showing £1 million being spent in 1 week and nothing the rest of the year. We've got plot B showing an even amount of spend across the whole year. And we've got plot C, let's call them two kind of campaign boosts spending that £1 million. So if we've estimated the diminishing returns curve, for argument's sake, let's just say Ted's example of the log curves earlier, we'll have a log with a power of 0.5 on it and quite a long add stock of 70%. We've got a curve in place. How different would the payback from each of these laydowns be? So actually, flattening spend across the year could improve contribution by about 22% compared to the doing 2 campaign bursts, while a single high week at the beginning of the year would measure as only half as impactful. Now, not only does this kind of result show how appropriate planning can garner improved results, but also more relevant to the discussions today, illustrates that choosing a realistic way to define a year of activity with which to populate an annual planning tool will be really important and much more realistic. So revisiting our problem, if you need to define a typical annual performance, but have weekly curves to do this with, fundamentally you need to simulate a sensible year of activity and then plot a curve relevant to planning a year's worth of payback. I've noted a few tips that we kind of tend to do on actual projects and ways of treating this problem. So either you could choose maybe to model a flat laydown, placing even amounts of media into every week of a plan, or possibly you choose a typical period, maybe the last 52 weeks that you've witnessed during the modelling stage. And then these laydowns can be up and down weighted to find the media contributions arising from more and less investment, and hence you produce your annual curve for your plan. Another common challenge that creating aggregated curves could be across campaigns. For example, maybe you've estimated effects from 2 different TV campaigns separately in the model, but you want one curve for TV. In this case, again, just a few notes and ideas you could do. You could possibly just sum up your curves. In other words, at each level of investment, sum up the incremental contributions you see from each campaign curve and replot those points. That's not advisable because here you'll double count the spend and create a curve that has too much payback. It's better to average the curves. What I mean is, for each level of investment, take the average incremental contribution that you measure across the campaign curves. This is usually fine if you kind of want to understand an average campaign performance. It's just best to be clear that that's the assumption you're making when you're then building your tools. The last challenge that we'll visit together is thinking about global portfolio analysis. So it could be quite common to maybe require a total media curve for each brand and country combination, but commonly MMM models are tasked with uncovering the impact of media channels in isolation. So how to bridge the gap between separate media measurement and total media uplift. In this situation, again, we need to decide how best to aggregate 2 or more curves together. Again, there are a few options in this case, but I've kind of split them out into a few pros and cons. Summing the curves, as we mentioned just previously, isn't advisable because you might double or triple count spends and create curves with too much payback. Again, averaging the curves is more realistic, but it's only appropriate really if you're planning on spending exactly the same amount in any channel, which isn't very likely. So then we get into more sensible options, the last 2 options listed in this table. You could maybe assume kind of a sensible media mix, something that you've possibly seen from the past, the last 52 weeks of a model maybe. Keep the proportions of that media mix channels proportions fixed. And this is better, but it doesn't properly account for the fact that some channels maybe will saturate quicker and they wouldn't be used at higher levels. But possibly the last option, to get the most optimal mix, you could actually optimize the media mix. What I mean here is that at every spend level along the curve, you actually optimize the mix across channels and plot the corresponding contributions that's predicted. This is probably the least bad solution. It's one that we commonly put in place on projects. But what you do need to be aware of here, that this will create your theoretical best case answer when reviewing the projected sales and ROIs. But here again, we're seeing creating some annualized curves to use within planning tools. So we visited a few examples of how moving from modeled response curves to planning with tools highlights a number of conundrums. Hopefully that's kind of opened our eyes to what we need to think about when we're actually working in the real world. And so we're going to move on now to discuss some more real world stories between us.
Cool, thanks, Ros. Dave, I think you had a good example to kick us off.
Yeah, I had a good example. When I worked for a large CPG manufacturer, they really used our average ROI as that was the key metric people focused on. So it's not that, people understood in the back of their mind that, diminishing returns existed. So they won't they won't allocate all dollars to the highest average ROI item. But just having those metrics so top of mind in every communication, every meeting, almost inevitably led to some over allocation or kind of misallocation of the budget towards something that had the highest average ROI, but maybe not the highest marginal ROI. So it almost consistently led to, difficulty making the plan next year because the budget wasn't really allocated in the right way.
So Dave, given you said part of the reason for that was just the simplicity of taking one number into a meeting, do you have any thoughts on like what's a better way of doing that in a
and that's absolutely right. I mean, the technology of taking a list, I can write a list of numbers on a piece of paper, take it into a meeting. That technology works very well because I just bring the piece of paper with me. It's better. So two things are better. So one, it's better to introduce the people to the concept of a curve. Just showing one example curve can be helpful to explain to people that it's more complicated than just looking at the average ROI. But I think the best solution is having, tools that you can use in the meeting that incorporate the curve so you can make changes on the fly. So you could get a group together, discuss what a budget might look like for next year, simulate it, and then make changes based on feedback.
Yeah. And I mean, even if you can't do that in the meeting as well, what we tend to do, if we can, of course, it always time reliance, having helpful clients and useful stakeholders, but getting hold of the kind of, if there are plans for upcoming bad budgets, running those kind of optimization problems before a meeting and having them as content. So you will visit average ROIs as content. People maybe have their ideas of what they saw last time as well. But we always like to then step onto, but if we think about an optimization problem, if we think about what your upcoming budgets are, here is what the model maybe suggests is the more optimal. Does that exist? The better way of spending those budgets. So yeah, if you can't do it in the meeting, if you can pre-prepare and go with that idea as well, I think that really exemplifies what the curves mean and what the impact is on planning.
I agree, because people, the curve is the diminishing return is very intuitive. When you show people a curve, people really do accept it. And I find it almost relieved when they see the curve, because before the curve, they would have to justify everything in terms of average ROI.
Yeah, I think it's always good as well. Like I always tend to try not just to show average ROI numbers. And even if you can't do a curve, if that's a step too far for an audience, talk about the what it may be, the revenue and the spend that's made that number, because you can get to the same number with different revenues, different spends. It's not always equal. Sometimes there's a channel that drives a lot of volume for a company, but its ROI doesn't look great. But actually that volume can be very important and can have a role in its own right. So I tend to also try and, if a curve is too much, at least just showing the two halves of the equation that the ROI comes from as well.
Right. Yeah, I agree with that. And again, I think just showing, obviously you don't need to show 20, I don't think you do need to show 20 curves. Just showing one example curve can be very, very useful.
But the key is just communicating that ROI is dynamic, right? It's not a fixed thing. It depends on where you are in terms of level of spend.
Right. Absolutely right. I think, and people understand that intuitively. It's just better to bring it transparently into the communication process.
Cool. Going to flash up a visual with a couple of interesting shaped curves that I think we've all seen in kind of real life situations. Ted, did you want to say a few words about these?
Yeah, sure. Just another example of a thing that's happened more than once. I used to be part of a process where we'd report out to the client in a deck many things, but focused, of course, on efficiency metrics like average ROI. And then in a secondary share out, come back with curves. And what would often happen somehow is with the focus on getting that first delivery done and making sure that all made sense and all the numbers added up and that everyone believed it, socializing it, somehow we wouldn't necessarily review the curves that the model had produced until we were going to present them. And you could end up with some very interesting shapes, like, this kind of square shape on the left. It's very hard on optimization. It just says you're going to spend above the angle and stay there. And, most of us would say that's not how most media works. And my other favorite, of course, is the one on the right, where there's very little effect, and then all of a sudden it breaks through past any level that has ever been seen historically. And clearly, you know, the company should just stop selling stuff and only run this ad because it's going to return so much. You know, it was just always alarming to us. Be like, oh yes, we've gotten buy-in on the results, and now we've got these horrible curves, and we're going to have to explain how they're related, but we can't directly use them in an optimization, and that's a bad place to be.
Yeah, I've certainly seen when there's a disconnect between the modeling team and kind of the actual marketing team who are making the decisions. That's when these kind of things could cause a real problem. You almost need someone in between to sense check the curves, add some sensible constraints before you can start using that in tools.
Yeah, and I do feel
ideally
like
you solve it in the model, right?
Sorry, say that again.
Ideally you solve it in the modeling stage.
Yeah, I mean, to your point, I don't know if it matters where the review happens, but I do think you need to be reviewing the curve shapes as you go through, right? Like we just should have a process or a tool where when I run the model, I can see the curves. And then maybe that needs to be reviewed by someone who knows the business. I think that's probably ideal. But even at the, like, I am just an analyst who is punching the buttons and being robotic about it level, I think it's pretty clear you don't want a square unless you have a strong justification. You don't want exponential rocket ship either, right? Like hockey sticks are great for revenue and weird and response curves. It just doesn't make sense.
I think it's also useful to kind of consider, because I know we've had ideas of like what might people be asking, what might people be thinking when they're watching this webinar, but how to judge the curve, how to know if this is right or wrong, even if you can't quite get your mind around what does this curve mean. If you look at your modeling results and you look at what is the shape of my media investment or whatever it is I'm measuring, what's that shape through time? What's the shape of its impact? Conceptually, that is what the curve's giving us, but you can look at it in an even more simple state, maybe looking at the decompositions, brand paintings, whatever you may call them. And if you see your shape of media through time and it's got some nice ups and downs in it, maybe there's a point in time when, you know, spending went up a notch, but actually the impact that you measure through time is just flat. You know, it's just square, or it only appears at very high weeks of spend. That would be what these curves are making happen. But you could judge it just by looking through time, looking at the shape of that impact, and then seeing if you feel that's real. Like, well, if I've got this level of investment in this week and it doesn't show up in my result, here I've got this level and it does. Think of it in that way. You don't even need to think about the curve. Think maybe you've got a bit of an odd curve behind the scenes, but what is the impact you're seeing in week, to kind of get you around a bit if the curves are making sense.
Yeah, and I think it's also how many data points you have. So the square point, you know, the square chart, you know, that can often be the case. There's maybe one outlier point that the curve's trying to fit through, that created that. It's sort of obvious when you put the points on there. You see, okay, it's only one, you know, it might be only 1 week of media that's generating, you know, that cutoff.
Okay, thanks guys. We've only got a few minutes left, so let's move on to the Q&A. We've got a few questions, I think, so thanks to everyone that's submitted a question. Let's have a look. So we've got one here. Is there a best point on the curve?
It depends on your audience. Who's asking me? The marketing team or the finance team? I like them all. I like all my points equally. I'm trying to think of a more serious response to that question.
If you've got the margin information, you can.
Yeah, because it's hard to, you know, for the best point in the curve, you know, I usually always think of it, I don't think of it in a context of one curve. I usually think of it, well, you're comparing across different media channels. So the best point, you know, I think of the best point is you want to, you know, maximize profits of the company. You know, the point that does that tends to be when the marginals are equal across the curve. That indicates that you've allocated the dollars correctly.
Yeah, I think it can be quite, not necessarily dangerous, but it can be if you know the context of what the company's been doing. Very rarely is a media used in isolation. There tends to be multimedia campaigns, different things come in over time. And so a media curve, it doesn't exist on its own. So one point on one media curve doesn't necessarily tell the whole story. So I would say always, the answer is it always depends, but it depends on, well, what investment is it that you're trying to find the best point for? So I think saying what you said, Dave, in another way, maybe think about your total budget, to Phil's point, thinking about the profitability of that budget, because you can plot profit curves against spend and find the point where, okay, you've maxing out your profit with a total budget. And then when you've got to that point, is it £1 million? Is it £5 million? Splitting that across the channels based on the curves that you know of. Because we know this from budget sizing exercises, you can get a different answer of what an optimal mix would be depending on your budget. So maybe you need to start from the top down, find the most profitable number, and then split that across the curves. So one curve by itself won't give you the answer, but you have to choose your direction of the problem solving and then use all the curves together.
Yeah. Cool. Interesting one here. So someone who has got results on a tactic where they're not spending a large amount, but that the ROI is quite high and good on that. So how to think about increasing spend, given the uncertainty about how far you can extrapolate a curve. Any ideas on that?
I mean, the textbook responses don't extrapolate. I would say the practical responses don't extrapolate far. Right. And I would just call out that one way to use that add budge function we talked about earlier, there's the row parameter in the denominator fixes where your saturation happens as you approach infinity. So as you start to see a sharper fall off, you can, shall I say, cleverly, a priori is the best word, fix that row so that it's a little bit into the, far out, but not too far out to be unbelievable. So that's not a measurement-based answer, right? That's a practical application of optimization for marketing decision-making answer. And again, not to tell you to go read that paper, but John Little's typewritten script that I linked to calls that out as an explicit use case, like tune this curve to be believable. So again, that's not a model-based answer, but it's a very practical one. Just make sure it doesn't saturate too far out.
Yeah, I even think post-modeling, it's interesting that in that recent Google measurement playbook, they recommended that you limit any kind of big budget shifts to plus or minus 20%. So even if your optimization is saying spend loads more in this, do it in increments up to 20% is arbitrary, right? But that seems reasonable. And then test that, see what happens, re-estimate your curve. Does that make a difference? And then continue in that way. So I think that's a sensible approach rather than going kind of gung-ho into channels that aren't yet proven.
Yeah, and I think that's how we do most optimizations, is put some kind of constraint in how much money can go around, whether it's, 20%, 30, 40, there's some range, so you're not increasing something by 10 times.
Yeah. Got loads of questions, more than we're going to be able to handle, I think. So maybe try and do one or two more. So I've got a couple about how going into more depth about how to best combine curves, specifically weekly into annual. I think maybe we'll pick that one up offline and kind of run through that in a bit more detail.
Or kind of putting things into action until you've done it a few times, it can be, quite a lot to handle, but it's
very important question though.
Yeah, and there's one about non-continuous marketing variables. How do we feel about those, and does that mean can we still use add budge, or does that constrain the use of different response functions?
So I guess it depends what the question setter means about non-continuous, as in media that's used in bursts now and again, or something that you don't expect to have an ad stock. So I think ad stocks and ad budge, that doesn't matter. There's no link or reliance there. And then media that comes more in bursts through a year, I suppose, again, it comes down to whether you're actually seeing varying levels of media being used at those times. There are then, I always love to talk about all of the different complexities and everything you need to take into account, because you kind of think about one thing, but there's also then all of the tie-up of, is there seasonality involved? Are you seeing a variety of uses with other stuff going on too? So maybe this also highlights the difficulty of getting measures for media independently of other factors that you're also trying to understand. But I think if you have a good range of different levels of investment happening in those different bursts. It's not always just very high at Christmas or just very low at lower times of year, because that can be harder then to estimate good curves through those. But if you've got a good range of measurement at the bursts that happen, I would think you can still estimate an average curve if you want to through them.
Yeah. Okay, very sorry, there are quite a few questions, so that's all we've got time for today, I'm afraid. So apologies if we didn't get to your question, but we will follow up directly with you in the coming days, and all attendees will receive a link to the webinar recording in the next day or so. I'd just like to leave you with a couple of closing remarks, just kind of summarising some of the key points we've said. So hopefully we've convinced you that don't make the mistake of planning based just on average ROI. So ROI is a dynamic concept, so you really need to be using response curves for simulating and optimization. When actually estimating curves, so the good principles to follow are parsimony, as Ted explained, and having this solid theoretical basis of how we know media and marketing works. As Ros explained, when we come to applying curves in practice, that involves some nuance as how they're estimated directly in the models. It isn't necessarily exactly how we want to use them for planning. So the key thing is to be aware of those differences and being able to think through the implications of what it is that you're looking at. So if you're looking at a curve, making sure you understand how to interpret that and what assumptions were baked in when that curve was calculated. So that could be about how time is accounted for, different flighting patterns, or the media mix. And if you're creating curves, then I think exactly the same thought process needs to apply, which is for the specific business question that you're trying to answer, what is the most appropriate kind of curve to derive, because there are multiple different options. And finally, yeah, we think curves are super important, but using them in the right way does require a bit of know-how and the right tools. But we hope you found this useful. Thank you very much for your time, and wish you a good rest of the day. Thank you. Bye-bye.